Okay, so I'm recording and it's time for class to start. Hello, Daniel. So until Enrique gets here, we'll just get started. Questions from Monday?
I would like to revisit the function on, I guess, problem 1 and 2. I was going to look at them online on the YouTube video, but I cannot find the link on here. But could we just revisit it?
Sure.
Like when given the function f is x.
Mm-hmm.
Equals
Why don't you
-2.
write that on the board?
Okay.
And we'll talk about it from there. All right?
Yeah. I can do that.
Aha. Well, good thing we don't need it. You can just move that cart out of the way if you want. You don't need to try and work over it. Okay. Now, that's an interesting question. Did you look to see what E means? Okay. So come on and sit down. We'll talk about this particular problem. Okay, we're looking at question number, that's number 1 on the homework, right?
Yeah.
Okay, question number 1 is f of x, meaning a function dependent on x equals -2 times e to the x. And you want to evaluate it if x is 3. So what you're evaluating is something that is -2. Let's write that down. So now we just substitute this into the formula. So we got -2e cubed. And that is, all you're doing is determining that value. Now, you have to know what e is. E is an irrational number. Okay, remember what an irrational number is? No. An irrational number is a number that cannot be expressed as a ratio of 2 integers. In other words, as a fraction. Like pi cannot be expressed as a fraction. So E is another one of those irrational numbers. It's also considered a natural number, as is pi, because pi is consistent for every single circle. Okay? E is used in other forms of engineering and other forms of math, but it is a natural number. And why don't you look at the value? Just type into your browser, what is the value of E?
$2.71828.
And it goes on forever.
Why? What is E? What is this E for? I've
Does
never heard of
it-
E.
Does it tell you the definition of E there?
No, it says the letter E is also the first letter in Leonard Euler's last name. As a mathematical constant, the number E remains the same value no matter what math you do to it. It will always be approximately 2.71828. I say approximately because the number E, like the number pi, is an irrational number. So that doesn't really give me a full definition of what E is other than the first letter. Euler's
E is
name.
the E, Euler, E-U-L-E-R, Euler,
Euler.
A German mathematician. It's a German name,
Okay.
Euler. E has its function in what we call natural logarithms, which are functions of natural processes and rhythms like sine waves and that sort of thing. We won't go into that. It's a physical and mathematical property, just like pi is a physical and mathematical property.
Okay.
For a circle. So E is used in a lot of a lot of advanced engineering and a lot of things like electronics and other areas. The fact is that E is an irrational number. This approximate, and one way of denoting something that's an approximate is to put that little, like the ñ in Spanish, over right in front of it. That means about. That means because we don't know. It's as an irrational number, like pi, it goes on forever. Okay? Except that we don't have any nice cute puns we can make like Pi Day and March 14th, 3.14, that sort of thing. We can't do that with E, because what's the 71st day of the second month, right? Can't do anything with that. So we don't have any nice fun things to use. But in this case, quite frankly, to evaluate that, I would shorten this down. Remember the rounding rules, 8 is more than 5. So we add 1 to the previous digit, 2.72. So round it off to 2.72 and then just evaluate 2.72 to the third power. If you want to carry it on out a few more places, go ahead. The number will change as you square and then cube. But that's all that is. So this function, f of x minus 2 to the e to the x, so you figure out what e cubed is, and then multiply that by minus 2. Okay. This formula comes out of physics someplace. I'm not sure exactly where. But it is the idea here. Remember we talked about functions. So E itself is just like pi, a number. We call it a natural number because it is a component of natural phenomena, just like pi is a component of natural phenomena. Okay. E is a constant, first I think characterized by Euler. That's why it's given. That's why it's abbreviated E for his name. But that's the way that works. Okay. That make more sense now, Jessica?
Yeah, definitely. Was that in the YouTube video?
It should have been. Were you not able to view that video?
No.
That's one of the ones I did not, of course, check. But if it's not viewable, anytime you run into a video link or another link that doesn't work, let me know.
Okay.
We're really trying to work throughout the organization on correcting these errors.
It's not the link in the thing itself, it's the link to the assignment in the modules.
Really?
I just don't know where it's at. Am I just super blind?
Okay.
Is it the self-assessment?
Let's get my glasses on so I can actually see your computer
Week
screen.
3.
Okay, so you're going to week 3.
Is it the self-assessment? Because I didn't think
It's not the self-assessment.
Did you guys find it?
Oh, for Pete's sake.
I didn't even bother to look.
Oh, I did when I got stuck on the first problem.
Well, oh, you could always type the link in too.
Yeah, I didn't think that. I did like this.
Okay, you could always do that.
Yeah.
Let's just take a quick
Let's check it.
look.
Maybe it's not published.
It might not
I mean,
be.
you find it in modules, right?
Yeah, I'm looking in modules, week 3, exponentials, and all I have is week 3 overview, the self-assessment, the research paper final, and the discussion, and the week 3 in-class group problem-solving exercise, which we'll get tonight, and then Zoom sessions. Zoom session video.
Okay.
Yeah, she's
That's all I have.
I'm looking at week 3 too, and it's saying some stuff.
Did you find it online? Jeffrey? Did you find it
Let's
online?
see.
This is the group, the in-class group problem solving exercise, right?
Okay, no, it's not.
No, this is Matt.
Okay.
Matt.
All right, here's my problem. That's been unpublished.
Oh, no worries.
So now it's published, even though I need to edit this. It's worth 60 points instead of 120. So I'll get that taken care of. So I apologize.
So you see this in those 3 modules now?
It's now in it should now, if you refresh your module, if you refresh your screen, you should be able to see assignment 3, which ought to be that one. So we'll just check it out.
So exponentials. Okay. Was this handout that this you passed out? What is that? What assignment is that?
The one I passed out the other day, that's the in-class, that's the, that is this assignment. That's the homework. I just gave it to you as a hard copy.
Mhm.
But now it's here.
So it's not actually
pretty-
due to the 19th.
No, it isn't. Yeah, all of the assignments are due on the weekend. If you get them done earlier, that's fine. I mean, I have no problem with that.
The only thing that since the 19th is Saturday,
Yeah,
we can't turn them in until Monday if it's a hard copy. You know what I mean? We have to do them online if we choose not to turn them in tonight.
don't
Right?
worry about that.
Okay. All right.
I
no
will
worries.
not hold that against you. You will not lose credit.
No.
If I choose to give you the assignment and in hard copy, and you choose to do it on hard copy, well, then I have agreed, without actually doing so, that you can turn it in at the beginning of class on Monday.
Okay.
Okay?
Thank you.
Bernard, yes.
I just really hate the whole class up, but I actually have a question.
Sure.
On this assignment, this last week's assignment.
Yeah.
See, I keep getting stuck, man. I don't know. I can't find the tutorial in this, but I get stuck when I come across these problems like this.
You can erase the rest of that stuff if you want.
Oops. Alright. So, trying to find it. Or just something like this. Like that. These ones.
Okay,
That's when I just multiplied.
that's x squared. The little caret thing says that that's supposed to, the next number is an exponent.
So that's really like this.
Yep.
So I'm just
So that's 28x squared y.
So I would just rewrite that 28x squared y.
That's right, yeah, exactly.
And what happens to the 2? Oh, and then
That's because in Excel, the only way we have of doing that is to use the caret symbol. That's what Excel uses when it shows powers. It uses the caret symbol to say that whatever the next letter is or the next number is the power to which this previous term is being raised.
Okay.
Okay?
Yeah, that makes sense.
Yeah, it's a limitation of
Technology?
Excel,
Yeah, okay.
of the technology.
Yeah.
Are you done then? Or do you need a little more time? Looks like you need a little more
Yeah,
time.
because I wanted, because then I was getting confused on that.
Yeah, we're
Those are-
factoring. Well, we'll go through some. Yeah, okay. We'll look at a couple of other factoring
Okay.
things, okay?
Yeah.
All right. All right, so two things. We'll quickly go over factoring, and we'll factor some quadratics. We'll do that. We'll factor do some general principles of factoring first, and then we'll work on quadratics again. Just do a couple of examples, and then I'm going to show you another way of solving quadratic equations. There are actually several ways. And I think what we'll do is we're going to concentrate on factoring and on using the quadratic equation. And the quadratic equation is a general formula for solving quadratics that can't be factored. The thing is that it works on quadratics that can be factored as well. Okay. So it's a good fallback. And in general, if all I say is solve the quadratic equation, use whatever method you choose. If I say factor, if I say solve it by factoring, then you do that. If I say solve it by the quadratic equation, then you use that. Okay? And I will do that simply because I want you guys to practice both of those approaches to solving. You know, the quadratic equation is plugging a bunch of numbers into an equation. Now, it will lead to some funky answers, and we'll get some funky answers tonight. And then I have another in-class exercise that I'd like to get to as well. And Daniel, when time comes, I will email a copy to you. So don't worry about that. So what I want to do is get out of here and get back to here. Okay, so factoring. Remember, factoring is merely pulling common elements out of expressions. And we'll do some very simple factoring first. And what I mean about elements. The expression 36x squared y has factors. Okay? And some of the factors are x, y, x, and x squared, and y. And we can choose whichever ones we want. But the thing is, factors are just components when multiplied together give you the expression that you're taking apart. And then, of course, remember 36 can be taken apart into its factors as well. Okay, 36 can be factored as 2 and 18, as 2 and 9, and as 3 and 3. Okay. And then if we just multiply these components along with this last prime number here, 2 times 2 times 3 times 3, is 36, right? So we know that 36 can be broken down, okay? The last stage would be 3 and 1. Okay, so if we just take this column and multiply it, any of those. So we could say that factors would include 4x squared times 9y, 36x squared y. Those are the two factors of that monomial. Now, we don't generally bother to factor monomials, but I want you to understand that everything that is not a prime number has factors. And even a prime number has at least one and itself as factors. All right. So let's take a look at a binomial. I'll just make one up. 25x squared y to the fifth plus 50 x squared y squared. Okay. So common factors there. And what we usually look for is when we want to factor things out, we generally try to go to the greatest common factor. And the reason for that is because we want to limit ourselves to one answer. Otherwise, we've got lots of answers there, right? 5 times 5 is 25. 5 times 5 times 2 is 50. So there's lots of things there. But 25 is common to both of those, right? So if we take 25 out of here, okay, we've got x squared, which is common to both. And we've got y squared, which is common to both. So then all we do is divide this common factor into here. We get y to the third plus 2.
I like
Right?
Right.
Does that make sense?
Mm-hmm.
Okay. So that's how you factor terms like that. And note that I've just limited it here to a binomial, but it could be a trinomial. If we had another term, 75, x cubed, y cubed, then we'd have another term, that's all. So the issue here is to pull out something that is common to every term. And that's all factoring is. Jessica.
If you had another term of 75 x squared y squared, and then you added that in there, so it would be plus 2 plus 3, would you be able to add those together and it would just be plus 5?
You got it.
Okay.
It would give you a correct answer.
Oh,
But 75 x squared y squared plus 50 x squared y squared, I would combine first, right, into 125.
Yeah.
So one thing to do is, where possible, simplify. Okay. Where possible, simplify, meaning combining like terms. Now, if it were 75 x squared y squared, then they would be common terms. X squared y squared would be common. Remember that we're talking about common variable terms, because the coefficient can simply be added or subtracted or whatever. But we can't change what we call the order of a term. X squared y squared is just that. That is a variable term. And it's different from x squared y or xy squared. So we just can't combine those things. So we have to look at these things as being very much separate, right? So does that make sense to everyone? All right, so let's take a look at a quadratic equation. Now, remember I stated a difference between just a trinomial expression, which you can factor, and a quadratic equation, which you can solve. And you were given problems that factor these expressions, and they're just trinomials, an x squared term, an x, and a constant, an integer. So, but when we have an equation, again, we're going to break this into what can be multiplied together to give us this. And then we use those expressions to actually solve for the values of x. And remember that quadratic equations have two solutions. In general, there are some special cases where there is one solution, but those are cases where both solutions are the same. And those are a special set of quadratic equations. In this one, I have deliberately set it to where it isn't the same. So what we want to do is remember that there are two things that we want to look at initially when we're structuring this, and that's the signs of the terms. Okay? We know that the solution is going to be x, going to be two binomials multiplied together. And it'll be x plus or minus some integer and x plus or minus some other integer. But the thing to remember is that, and let's just call this A and B, just as examples. All right.
Okay.
So if we look at the positive sign on, remember the general formula, actually I don't want A and B, so I'm going to use those for something else.
No?
Excuse me. Let's make those M and N. Because remember, the general quadratic equation is ax squared plus bx plus c, where a, b, and c are integers. Okay? They're real numbers and rational numbers. So we know that the x will be plus or minus m and n in these expressions. So we can set this up right away. We know that our answer is going to be x plus or minus an integer and x plus or minus a different integer. So what we do first is we look at the sign of c. In other words, the integer component of this equation. And if that is positive, then then M and N are either positive or negative, but they're both positive or both negative. It's the only way you can get a positive when you're multiplying. If one is negative and the other is positive, then then it's going to be a negative number, right? Okay, so then we also look at the sign of the B in this case. The sign of 8 is positive. That tells us
The M?
that M and N are both positive. Because if it's not, it will not likely show up unless they're 0, but they're both going to be positive. Okay, it's our first bet. So now we know that the answer here for this one Now we just have to figure out what M and N are. And we do that by looking at C and doing a list of all factors. We know they're going to be positive. So 12 is composed of 1 and 12. Never forget the 1 and the value of C as a potential pair of solutions. 2 and 6, 3 and 4. Now, we don't worry about the fact that it can also be 4 and 3 and 6 and 2 and 12 and 1, because we already listed those. So what we want then is a pair of those that adds up to 8. Right?
So x plus 2 and x plus 6. So then,
Yeah.
do you want us to break it down further into x equals -2? X equals
Well, we're gonna get there. What I'm trying to do is do the factoring first, and then we'll go to the next step, which is calculating the solution. Because the factoring is, some of the problems you're being asked are just stop at factoring, and you can then say, well, if this were an equation, which those that are just factors are not given an equal to 0, right? If it were an equation, then these would be the solutions. But if you're just supposed to factor it, then that's where you'd stop, right? But here now, we're going to say that, so the x, and this is all equal 0, x plus 6 times x plus 2 equals 0. And it doesn't matter if you say x plus 2 and x plus 6, because you're going to get the same answers, right?
Why is M in 3 and 4 though?
Well, 3 and 4 add up to 7. What you want is a combination of M and N that add up to plus 8. And the only way that works is if you have a 2 and a 6. Jessica.
On our homework, since there's not an equal to, there is an equal to 0 past 20, but on 13 through 19, do you want us to leave them in that form?
Yeah, just leave them in that form. That'll be the correct answers. Okay, so now, when we're actually solving these equations, what we do is we set each of these factors equal to 0. So we have x plus 6 equals 0 and x plus 2 equal 0. And now you know how to solve this. So x equals minus 6, x equals minus 2. So right? So if we substitute those values back into that equation, what we'll do is we'll find out that if we put minus 6 into the equation, we're going to get minus 6 squared, which is plus 36. Remember, minus 6 times minus 6.
Can you write it on the board for me? If you were to rewrite it? Yeah.
Sure, of
Just
course.
that visual helps a lot better.
Oh, you bet, no problem. Okay, so we're going to say x equal minus 6. Put a question mark there because we're testing it, right? Okay, so we've got minus 6 squared. Don't forget the negative inside the parenthesis, because minus 6 squared written like that is different from minus 6 squared
Without the parentheses?
without the parenthesis. Minus 6 squared is 36. Minus times that is minus 36.
Right.
Okay. So don't forget that. That is one of the places where if you make that error, it'll give you the wrong result, right? So minus 6 squared plus 8 times minus 6 plus 12 equals 0. We're still questioning that. So this is 36. 6 times 8 times minus 6 is minus 48 plus 12 equals 0 plus 12. And indeed, that's true. So that's how you check it out, Bernard. Jessica.
So if it's a -6 cubed, is it going to be a negative number?
It'll be a negative number.
Okay.
Yes.
That was my only question.
No, that's a good question. I like that. It's going to be minus 216. So yeah, squares are positive numbers. Even powers, squares, 4, 6, 8, all of those will be positive numbers if you have a negative or a positive. Uneven powers, 3, 5, 7, etc., will be negative.
If we plugged in the -2, is it going to be wrong?
No, -2 is shown now to be a solution. So let's do that. Okay. Again, -2 squared plus 8 times -2 plus 12. -2 squared is plus 4,
Plus
right?
4. Yeah.
4 plus, and 8 times -2 is minus 16 plus 12 equals 0. Yeah, you got it. Good, good. Yeah, that's a good idea, and I can't emphasize this enough. It's always a good idea to check the answers that you get. And the reason that I want you to do that is it's easy to make little mistakes. Okay, and the usual mistake is when you are not paying close attention to the signs of your numbers. And we all do it. I can't tell you how often I prepare an answer key to your homework, and I prepare that answer key in about 10 minutes flat. And you know what? I've gotten real sloppy in my old age, I guess. Because when I start grading, I start reading down there and somebody gets one wrong. Well, my first, when I'm doing this, my first reaction is to go check my work. Okay? And inevitably, at least one of my answers is indeed wrong because I've made a sign mistake. It's happened on every assignment we've had this month. And it's kind of disturbing to me because I don't usually make that many errors. But I certainly have. And so, but you know, what I'm telling you is that I'm not sitting there saying, well, my answer has to be right because I'm the instructor. Yeah, right. So I go through and check, and it's happened. And I think with each of you, I have found that you found my mistake. So, and as a result, I'm very careful about not deciding that just because you have something wrong, that you have to be wrong. Sometimes you are. And it's usually something silly like subtracting 8 from 11 and getting 9. Or something like that. You know, just getting the wrong answer. And it's a silly error. I don't knock you down full credit for any of those. But you know, I do. That's why I want to see your work. I do check your work. And if you've done everything right but made one simple mistake, and I will tell you right now, the most common mistake that I saw in the last homework, which I apologize, I haven't posted the grades yet, but I have them. I'll be doing that while you guys are working on the in-class exercise. But the most common mistake was forgetting that when you divide an inequality by a negative number, it flips the inequality. So if you have minus 5x is greater than 2 or greater than 10, make it easy on myself. Divide that by minus 5 to get x equals, and then it's less than minus 2. It switches it. That is what
Hey, can we get that one on the board real quick? Can I
Okay.
do that?
Yeah.
I want to see that because that greater than was getting me too.
Uh-huh.
I'm glad we brought that up.
All right, you okay with me taking this off the board?
Yeah, you're welcome.
Okay.
Yeah, the greater than, and I get stuck on those too.
Yeah, yeah. Inequalities are not something that we think about in terms of our mathematics very much. And so let's put that in inequality. Let's just say x plus 4 is greater than 3. Okay, so we have, if we're adding and subtracting from both sides, so we're going to subtract 4 from both sides, and that's going to be x is greater than minus 1. Okay, however, if you have minus 2x plus 2 is greater than 12, okay, just to make it a little more complicated, all right? We subtract 2 from both sides, and we get minus 2x is greater than 10. Now we have to divide by minus 2, right? Because we want x. Okay, so x divided by minus 2. So we get x is less than minus 5. When we divide by a minus, it flips the inequality. Guess what? If we multiply by a minus, it flips the inequality. Now, generally speaking, you haven't had to do that. But that is a place where it's not obvious, but think about it. If minus x is bigger than 5, okay, then if we reverse that on the number scale, in other words, let's look at the number scale. Okay, so if in the inequality, if negative x is greater than 5, okay, 1, 2, 3, 4, 5, so it's negative x is somewhere up there, okay, but we want x to be, we want to know what positive x is. When we do that, we have to reflect it across the 0 point, okay? Which now means has to be going the other direction. Right, that makes sense? Okay. So that was one of the more common mistakes made on the homework. And again, all of you guys did everything else right. You just missed that one little bitty detail.
Everybody missed it.
Not everyone, just a couple of them.
But a negative times a positive is a negative, right? So if you do divide a negative to a positive, it's a negative.
If you divide a negative into a positive, it's a negative, yes.
Right, okay.
Yes.
Yeah, if you multiply a negative times 5, it's a negative.
Yeah.
But if you multiply 2 negatives,
It's a positive.
so if you do. Oh,
How many
okay.
questions applied this concept? Was there more than one?
About-
I think there was something.
About 3.
It's like three or
I
four.
think 3 of them used that, 3, maybe 4.
Yeah.
Some people got them right and some people missed them. I also decided that that I would accept the inverse. Okay. Say if x is less than -5, then minus x was greater than 5. I took that too. Okay. Because I really want the concept. But I really want you to remember that when you multiply or divide an inequality by a negative number, you flip the inequality. Okay? In other words, it goes from positive to negative or negative to positive. It's like inverting. Okay? That makes sense?
Yep.
All right. Now, are you okay now with factoring?
Yeah.
Okay. A couple of things about factoring. You still look a little
You
troubled.
want to do
Bernard.
one more? You want to do
You
one
bet. You bet. I'll do one.
Yeah, just do one more.
Yeah, let's do one. Okay, x squared minus 4x minus 45 equals 0. Okay. Now, what do we know when we see that the last term, the c term, has a negative?
When you see, it's a negative.
Yeah, if it's negative, what do we know about, remember the values of
M and N,
m and n?
it's going to be negative.
Okay. One is negative, the other has to be positive. If they were both negative, that'd be a positive number, right? You remember m and n are multiplied together?
Right.
So we know that one of these is positive and the other is negative. So what I'm going to do is modify this. So we know that's the structure. So now, what do we know about that sign right there? That sign can be either positive or negative. But that sign tells us that the larger factor of 45 has to be negative. Because remember, they have to add up to, in this case, -4. So whatever the factors are of 45, we know one is positive, the other is negative. If the B sign is negative, then the larger factor of C has to be negative and the smaller factor positive. Because we know that one's going to be positive and one's going to be negative. Okay? So let's look at 45.
Yeah.
Okay, well, 1 and 45. Thank you, Katie. Very kind.
You just happen to look at the food, so any more? Sorry, Mike.
Yeah, go ahead. That's all right.
Any strawberries for you, Trevor? Anything for you, Bernard?
I just some grapes. Uh-oh.
There we go.
There you go.
Awesome.
A little lettuce for the healthy part.
Anything for you? Get the dean. Serving her students food. I mean, come on, I might want some or what?
Thank you.
Thank you. Enjoy your
Thank you,
week.
Katie. Are you on the way out?
Yes.
Have a
Drive
good
safe.
weekend. I'll see you Monday.
I'll see you. Thank you.
All right.
Bye, guys.
Drive safe.
Okay. So 1 and 45.
There we go.
3 and 15. And what I'm going to do is, since one is positive and the other is negative, I'm going to put a little bit of space here. Okay? Minus 1 and 45, and 1 and minus 45. Minus 3 and 15, or 3 and 15. Minus 5 and 9, or 5 and minus 9. Okay? Are there any other factors that make up 46? Pardon?
Minus 15.
Did I miss? Thank you, Trevor. Gotta watch me. Gotta watch me.
Okay.
All right.
Okay.
So
Is
of
that
those
necessary?
factors, pardon?
Is that necessary to do it like that when you're factoring?
It is a good way to logically think through the problem.
Okay.
I mean,
That's fair.
some of these you might look at it and say, okay, yeah, I know what the answer is, and that's fine. But really, what I'm trying to do is give a structure that's real general, especially if you happen to have some large number,
Okay.
you know, that has many factors. We can rule out a bunch. 1 and 45 can't add up any way on earth to minus 4. So we can rule those out even probably without writing them down. But I'd like to write them down because I never want to forget all of the factors. Okay? So what combined will add up to minus 4?
-9 and then a +5.
Right. Minus 9 plus 5 is going to be minus 4. So we now know that it's x plus 5 and x minus 9 are the factors. Does it matter which order? No.
That question you just asked, you figured those out. You said, what are the two factors that add up to 9?
To minus 4.
To minus 4? What
Minus
add up
4.
to minus 4?
Yeah,
What
well,
add up to minus 4?
we wanted to add up to this term right here, right?
Right.
The only two that can do that are plus 5 minus 9. Right?
Because that makes sense. That's
Yeah.
why that's necessary. Okay.
That's one of the reasons, because
Yep.
3 and minus 15 is minus 12.
Right.
So, you know, once you do this
Right.
enough times, it'll become a lot easier. You'll be able to rule out some of them
Okay.
quite easily.
Okay.
Like especially the 1 and 45. Either combination can't possibly give us minus 4. Okay? Does that make sense?
Yep.
So now we get down to x plus 5 equals 0, or x equals minus 5. And then x minus 9 equals 0, or x equals 9.
And 4x is B, right?
4 is just b. Minus 4 is b.
Minus 4.
Yeah.
Yeah, it's B. Okay.
Yeah. That's just b.
I'm just doing some notes.
Right. Right. Does that make sense now?
Mm-hmm.
Okay, let's introduce the quadratic formula. By the way, starting early next week, you won't be able to do anything in your shell until you do the student survey. Okay, if any of you don't have a student survey, please let us know. Sometimes, for some reason, some people don't. The other thing I want you to remember is that as opposed to the way the surveys have been done ever since I started working at College America 8 years ago, they changed the surveys. And so the what used to be on a 1 to 10 scale, where 1 was lousy and 10 was perfect, right? Well, they've gone the other way now. It's now, I think, a 1 to 5 scale, but 1 is perfect and 5 is lousy. So be careful when you fill these out,
Okay.
that you're actually saying what you mean. It's easy, especially I know everybody, sees these things and heaves a big sigh and then goes ahead and does it and tries to rush through it as quickly as possible. And I can't blame you for that. But be aware now we've inverted the scale so that if you really hate something, it has a low number. And if you really hate something, it has a high number. If you really love something, it has a low number. So
make any sense.
beats me why they did it. I don't know why that change was made, but that's what the organization went with. Bernard, question.
No, I'm just
Just computing.
yeah, computing.
Okay.
Right, just computing.
All right. So let's talk about the quadratic formula. This one's better. Now remember that our basic equation is ax squared plus bx plus c equals 0. And x is what we generally use, but the variable can be any letter of the alphabet. Okay, so it doesn't really matter. You've already seen some r's and some n's and some y's and some other things. It can be any variable of the alphabet. There's a long explanation, which we won't go into, as to how to solve this without factoring. Because many things can't be factored because you can't find factors that will add up to the b term, basically. Okay? So there is a formula. X equals b squared plus and minus the square root of, no, I confuse myself. I'm real good at that. So, especially since I've been staring at this all day, and of course, what's happened is I've gone gaga. Yeah. Actually, she's an amazing performer. Pardon? Yeah, well, she had to, because there's a lot of good voices, and in order to get noticed in rock, you have to be weird. Yeah. I saw a video of her with an old sort of jazz crooner,
Like in the
Tony
days
Bennett.
when she was a brunette. And
Oh yeah, and a
before
blonde, and
everything.
oh yeah,
Yeah, she was gorgeous.
she was,
she
and
was so
her
talented.
voice was so beautiful, and they sang together so well.
She was amazing.
And she actually embarrassed Bennett at one point real badly.
Another question. You
Huh?
think yourself a poker face or a better face?
I am definitely not a poker face. Actually, when I play poker, I'm a lot better. Okay. Minus b plus and minus b squared minus 4ac all over 2a.
Now this isn't a quadrant. This is a different.
This is the quadratic formula.
This is the quadratic formula. This is the formula for solving any quadratic equation. You just plug in the values of a, b, and c, remembering carefully to keep your signs straight. So it's minus b plus and minus the square root of b squared minus 4ac all divided by 2a. Now, why plus and minus? But remember that any square root can either be a positive or a negative number because you're multiplying a number by itself. Positive times positive is positive, negative times negative is negative. So if we have one of these two solutions, then our minus b plus the square root of b squared minus 4ac over 2a, and the other is minus b minus the square root of b squared minus 4ac over 2a. So this is consistent with the fact that every quadratic equation has two answers. So let's do a simple example.
Yeah.
Okay. Actually, let's take our 15-minute break, and we'll come back, and then we'll do a couple of examples. One that will be simple and one that will not.
Perfect. I'm excited.
it like rings a very faint bell.
Yeah. You probably saw it in high school.
It's coming back to me, I tell
Yeah.
you.
You've probably seen it before too, Chris. And you have too, Bernard, I'm sure, in your high school classes. That formula.
No, I didn't know. I actually got my GED
Well, good for you.
in prison.
Ah,
So I didn't stop.
they didn't make you do that? I thought the GED exam required it. That's interesting.
Yeah, just doesn't look familiar.
Okay,
Hey, so this was, I want a good question.
sure.
It says factor this though. So when we're factoring, is it that, am I gonna break down 28?
Yeah, break down each of those.
So both of them,
Yeah, because 16 and 28 are both even, right?
right?
So you know that each of them is divisible by 2. And you're going to get 8 and 14. Well, each of those are divisible by 2. So each of them now is divisible by 4.
Right.
Yeah. So if you divide 4 into 16x, you get 4x. If you divide 4 into 28y, you get 7y. So it's going to be 4 times 4x plus 7y.
So you do that. So you just factor this 16
Yeah.
by 2. That's 2 and 8, right?
Yeah, 2 and 8, and then we got another 2 and a 4, right? And then 2 and 2, and you're done.
So this is okay. That's where I got thrown off. When I'm factoring, it's 2 times 2. 2 times 2 is 4. 4 times 2 is
8,
8.
and then that last 2.
And
You know,
then
there's
8
one
times
more step, which
2.
is 2 on the left column and then 1 on the. Right. Now, those all multiply up to be 16. You can do the same thing with 28.
And then okay, so after I run this table, now which is it? The 2 is now the 2 is x. Does 2 become x now?
No, all we're doing is dividing each of the terms by the greatest common factor. So let's go ahead and do the same with 28.
All right.
Okay, you're going to do 2
2.
and 14,
All right.
and you got 2 and 7, and then 7 and 1.
7.
Yeah, and 1.
Now I'm lost.
Okay, well, 7 goes into 7 one time.
Right.
So you take it all the way down to 1. Okay? Now, if you look at that, if you multiply 2 times 2 times 7, that's 28.
Right.
So you've got 2 2s in that line and a 7. If you go over to 16, you've got 4 2s, right?
Right.
But there are 2 2s in both.
Right.
So those 2 multiplied together are your greatest common factor. So now you're going to divide each 16 and 28, 16x and 28x by 4.
Because and the reason why we did 4 is because you have 2 2s. You have 3 2s over here and 2 2s over here.
Right. So you want the most the one that has a common number of factors.
The common number of
Yeah.
factors. So because okay, I get it. That's what I wasn't
Yeah.
getting. That's
Okay.
because these 3 2, there's 3 over here and there's 2 over here. That's the most common
Yeah. So
factor.
2 times 2 is going to be the largest common factor of 16 and 20.
And so since you take 2 times 2, it's just 4.
Yeah. So you're going to divide each of those terms then by 4.
So in another problem, whatever that common factor is, you're gonna multiply that and then divide it up here. Okay.
Yeah.
Ah,
That makes sense?
yes, it does. Thank you.
Super.
I'm sorry to take over your.
Oh, no,
subject.
that's
It's
okay.
your break time.
That's what I'm here for.
Yeah, that's what wasn't clicking. I don't know how I missed that, but I appreciate that.
I'm glad we clarified that.
Yeah, I feel my anxiety has subsided away. So that just helps.
Okay, I'm going to run off and take a short break myself.
Man, it's amazing how you just have all of that in your Rolodex. Your Rolodex like that.
Well, I've been doing math for a lot of years. I won't tell you how many,
Yeah,
but it's been a lot of years.
yeah.
And I've taught this class a lot. So I had to figure it out.
Yeah, no, I know the Parker Bird you drive, it's always, I remember that one drive on the truck, yeah. I'm like, Ferdinand, Ferdinand, what is that? Like Parker Bird. Well, I've got two, but I drive and I don't have it. No, I do in the big one though. Big one's got that. John's not gonna be happy.
California sun.
Yeah, I know. Oh, you did explain that. No, I was gonna say, I noticed that Simon said I didn't get turned in, but you said you had,
I haven't,
right,
I haven't
right.
put them up yet, so don't worry about that.
Is everybody back?
I gotta get up there. All right, have a good rest of your class.
Sorry, I left six for some reason.
All right.
Blame it on the other instructor.
Okay, I'll blame it on John.
No, I don't know. I'm definitely ready for some quadratic formula explanations.
Liar.
Okay.
I detect a hint of sarcasm there.
Excuse me, sir.
Just a hint?
It's spending a pint of beer on a woman who just said, and a man who just exited the brewery.
Oh no. This is just an employee. He wasn't drinking.
He's just our beer tester. It's a fine, exquisite establishment, I say.
You're gonna break your neck and die one day doing that.
Only if I grab the chin wrong.
Strangest stuff, I tell you. Walking on the edge. Discussion first post due by Thursday? Or
Yeah.
Wednesday.
Thursday.
Thursday.
Tomorrow.
Definitely should do that.
All right, so let's get back up and we'll take a look now at the quadratic formula. I have an example up, and so what we want to do is, what I want you to do is remember that you need to remember this formula. Now, do I expect you to memorize this formula? Well, let me just say that when you're taking your exam, keep a copy of the formula around and refer to it. I don't expect you to memorize this. You remember, I just stumbled over it, so I can hardly, I can hardly demand more out of you than I can perform on my own. So keep a copy of it available. You know, what I've often told my students is, because a lot of times you'll get into a test and you'll forget something that you absolutely knew before you get in because you're nervous.
Yep.
Okay. In the medical area, when we take our certification exams, we can't carry anything into the exam room. Our cell phone is not allowed to be out. We can't have a calculator. They give you a calculator if you need it. Because they don't want people bringing in graphing calculators and little computers they can look up answers on, right?
Right.
So you can't have anything except a pencil and some paper. So what I say is that important formulas, memorize them. And when you get ready to start an exam, write them down on some of the scrap paper. That way, you don't get into the exam and suddenly say, oh, what was that formula?
Right.
I can't remember. We don't like that. Okay, so that's one suggestion. As I said, it's perfectly fine for you to have a copy of this formula available to you. So in reality, as I said before, unless you're told to use the quadratic formula, you can either use it or you can factor. This one's easy to factor, but I want to do this to show you how the formula works, and then we'll do it by factoring to show that we get exactly the same answers. Okay? All right. So the first thing you do is you make a little table. What is A, B, and C? So in this formula, what's A?
1,
Is 1. What's B?
7,
7. And remember, with no sign in front of it, the implication is it's positive. So if it's a negative, don't forget that sign.
Got
And
it.
what's C?
10, positive 10.
All right. So now we simply set up our formula. A equals minus 7, minus B, plus and minus the square root of B squared, which is 7 times 7, or 49, minus 4 times A, which is 1, times C, which is 10. Okay? All divided by 2A, or 2, which is 2 times 1, right? So now it's just a matter of filling in the numbers. So we've got minus 7 plus the square root. 4 times 1 times 10 is 40. 49 minus 40 is 9 over 2. And minus 7 minus the square root of 9 over 2. Remember, there are always two answers. So, what's the square root of 9?
3.
3,
Great, okay. So minus 7 plus 3 divided by 2, minus 7 minus 3 divided by 2, okay? Minus 7 plus 3 is what?
4, 7,
What sign?
negative 4.
Minus 4. Okay. Equals minus 4 over 2. So x is minus 2. This is a noise. Go to a different color. Okay, minus 7 minus 3 is how much? Minus 10 over 2. Okay, so x is also minus 5. Okay. Now, let's go back and factor x squared plus 7x plus 10 so that we show that we can get the same answer either way. X squared plus 7x plus 10, going to have, what do we know about the signs of M and N?
They're both going to be positive.
They're both positive. Okay. So 10, if we do a little factoring, we get 1 and 10. We get 2 and 5. And nothing else. So what adds up to 7? 2 and 5, right? So x plus 2 times x plus 5 equals 0. X plus 2 equals 0. X equals minus 2. X plus 5 equals 0. X equals minus 5. Right?
So that's your last.
So factoring or the quadratic formula gets us the same answer.
How did you go to negative 2? What'd you go at the end when you
Well,
factor it?
We set each of those factors equal to 0.
All right,
So we set x plus 2 equals 0 and x plus 5 equals 0.
right. How did you get the negative 2 down? How did
Well, x plus 2 equals 0, then x has, we subtract 2 from both sides, so x becomes minus 2.
you say both sides from the 2 and
Yeah,
0?
so we subtract minus 2 from the left side and minus 2 from the right side. So then we get x equals minus 2. Same with the next one, we subtract 5, right?
Okay.
Got it?
Yeah, I do.
All right.
I do.
So This tells us that we can get it either way. What this also says, if you look at something and say, I can factor this, solve it by factoring. Okay? Less steps. You saw there's a number of steps we went through just to create this other solution. It works, Trevor.
So for the Kojak formula for B, if it was a negative number, placing B would still be negative.
Well, if B were negative, in fact, we'll do one with that right now, okay? Okay. The reason I want to do that is that I'd like to actually illustrate that, because B minus B is a negative number, so we're multiplying B by -1, whatever it is. So then that becomes, if this were a -7, right, which it could be, because if it's a -7 and it's a +10, then we know that both of the factors, both M and N, have to be negative numbers, right? So if it's -7, then that's going to be +7. Minus 7 is +7. So that's why I'm saying be very cognizant, be very aware of the signs. Okay?
Let's do another one. Can we do another one?
You betcha.
Let's do another one.
Yeah, I'm going to do another.
Yeah, let's do another one.
Yeah. Okay, so I'll pick out this one. Okay, so in this case, we want to write down A, B, and C. So what's A?
1,
1. What's B?
5, -5,
-5. And C is
-36.
-36. So we want to get over here, and our first one is minus 5 plus and minus the square root of -5 squared minus 4 times 1 times -36. Okay.
So then that just becomes a +5.
Pardon?
So it's a +5, and then also the 2 makes it a +25 too.
So let's go ahead, yeah, that's right. So this becomes 5 plus and minus the square root of 25 plus, because we have a minus times a minus, right?
Plus 4 times 36.
Right, 4 times 36, which is 144. Okay. All divided by 2. Remember, we have to keep that in there. 2 times 1. So we've got 5 plus and minus the square root of 169 divided by 2. So what's the square root of 169? You can do this on your, and again, in any exam,
13.
you can use your calculators. 13, yes. So 5 plus and minus 13 divided by 2. So in this case, x equals 5 plus the square root of 13 divided by 2, and 5 minus the square root of 13, or plus and minus 13, excuse me, I'm sorry. Plus 13 and minus 13, all divided by 2. 5 plus 13 is what? 18. 18 divided by 2, so x equals 9. 5 minus 13 is?
5 minus 9 is 45.
5
Negative
minus,
8.
Oh, you said 5 minus?
minus 13.
Negative 8.
Negative 8, right. So this becomes minus 8 over 2, so x equals minus 4. Okay.
4 and 9?
Pardon?
Negative.
X is minus 4 and 9. We have to keep track of signs. Okay. Does that make sense?
Yeah. Because it's a negative 4, yeah. And then negative 9, yeah. Yeah, we did it.
All right. Now, again, that one can be solved by factoring. Anytime you come out with whole numbers, it can be solved by factoring as well. But let's do one that can't be solved by factoring.
For real?
For
So
real.
factoring doesn't always work, huh?
No, it does not.
Ah,
It does not.
all
All right.
About to learn today.
right. Right. Oh, damn
You
it.
got it.
Damn.
Okay. Now, all right. X squared minus 3x minus 1 equals 0. Obviously, that cannot be factored. There is no, 1 only has factors of 1 and 1, and there's no way that can add up to 3. Therefore, this is not factorable, and we will not get an even answer. Okay? So, let's start off as usual. A, B, C. What's A? 1. What's B?
Minus 3.
Minus 3. And C?
Can't see over your head.
1.
Four.
Negative 1.
I didn't think I was tall enough. Minus 1. Okay. So, we've got minus 3 plus and minus the square root of minus 3 squared minus 4 times 1 times minus 1. Okay? Make sense? All divided by 2a. Right? The setup is critical. That's the rest of it's just arithmetic. The setup is critical.
It's critical.
Right, okay, so now we have 3 minus a minus 3 is 3, plus and minus the square root of minus 3 squared is 9. And then we've got 4 times 1 times minus 1 plus 4 divided by 2. So this then becomes 3 plus and minus the square root of 13 divided by 2, or 3 plus the square root of 13 over 2, and 3 minus the square root of 13 over 2. And that's as far as you can go. I don't ask you to go ahead and find the square root of 13 and add and subtract it. Okay, that's not necessary. We can stop there. So this is one that you can't really factor. Okay, not in your head. So, and now x becomes, those two answers, 3 plus the square root of 13 over 2 and 3 minus the square root of 13, all divided by 2. There are plenty of other ways to express this. Some books would have you say 3 halves plus square root of 13 over 2. Don't bother. That is a sufficient answer. Okay, Jessica.
Okay, so I was hoping our next example we could maybe do the first one in our homework, just because I did it and I think I did it wrong, even though because it didn't when I went to check it, it didn't quite go in.
Didn't
So
go
I
in?
just
All
want
right.
to see where it went wrong.
Okay, so read that to me.
Okay, x squared plus x2 minus 5.
Okay, is everybody happy with me erasing this?
Yeah.
Yep.
Okay, so it's x squared what?
X squared plus 2x minus 5.
Okay.
This is the first one.
Yeah.
Okay. And we're supposed to solve this, right?
Yeah. I think
Okay.
I think I found my problem already though. I think I forgot
Okay.
Okay. I can do this.
Yep.
Okay, so 1, 2, 3. So no, see, I didn't. Okay, so there's the 2 squared. 4. 2.
Yeah, go ahead.
So
Keep
then it's
going.
just plus 20.
Right, plus 20.
Over 2. And so negative 2 plus. I see what happened. See, you just gotta do it twice, you know what I mean?
Sure.
24. See, because I just dropped the square root.
There you go.
Forgot about it. All over 2. So what's the square root of 24? Is it
Let's take a side trip into
Is
How
that
do
not a
we-
perfect square?
It's not a perfect square.
Okay, so should I just continue then? And
Yeah.
then we can, okay. So leave it in the square root and.
Leave it there,
Okay,
and I'll show you how to simplify that.
okay. Minus. Yeah?
Yep.
But I can't go further?
You can't go, well, you can, and I'll show you how.
Okay.
Okay. Let's take a look at,
This is not my chair.
let's take a look at how we deal with radicals, meaning roots, square roots.
Okay.
Okay? As a general formula, the square root of the product of A and B can be said to be the square root of A times the square root of B. Okay? So the square root of A and the square root of B are actually factors of the square root of AB. So what we want to do is look at 24 and see what factors of 24 there are
Like 4.
that might be squares. Yeah. So 24 is 4 times 6. Right? So it's the square root of 4 times 6. So this now becomes the square root of 4 times the square root of 6, which is 2 times the square root of 6. Okay. That's as far as we want to go. So this now becomes 2 plus minus 2 plus 2 the square root of 6 all divided by 2, and minus 2 minus 2 square root of 6 divided by 2. We can separate this up. 2 plus 2 times the square root of 6 is the same as 2 over 2, or minus 2 over 2, plus 2 square root of 6 over 2. Remember, when we add fractions with a common denominator, we just add the numerators. So we could split up something like this into 2 fractions. And now this is minus 1 plus the square root of 6, and minus 1 minus the square root of 6. So that's a simpler solution. Does that make sense? That help, Jessica?
That 2 just cancels out?
Yep.
Oh,
You're dividing 2 into minus 2. That's going to give you minus 1.
okay.
And you're dividing 2 into 2 times the square root of 6. So that gives you just square root of 6. Right? So it's 1 plus, minus 1 plus and minus the square root of 6 are the answers to that one. So we don't have to do any further calculations. You know, we could look up the square root of 6 and calculate a decimal number. I don't expect you to do that. I want you to get to the point where you can solve these things. The rest of it's just arithmetic. And this isn't really an arithmetic class. Okay? Does this make sense? Now, again, I caution you. I'm going to pass out the in-class work.
Oh, no.
And Daniel, I'll email that to you as soon as I pass it out. For you guys to work on it together for a while and probably end up finishing over the weekend because there's 20 questions on there. You're going to do some factoring and you're going to solve some equations by factoring and some others by the quadratic formula. I will tell you right now, these are not the only ways to solve quadratic equations. There are 2 other methods that can be used. I don't think we don't have time to go into them in this class, and I don't think it's terribly important, especially since these 2, factoring and the quadratic equation, work. Okay. In fact, the quadratic equation works all the time. Now, I'm going to ask you a question. B squared minus 4AC. might end up being a negative number. In fact, let's do a simple one. Now, have any of you tried to read the text, the online text? We do have an online text, and we cover the chapters of that text. Have you tried to read it?
I have.
You have?
Yeah.
Have you gotten anywhere with that? Has it made any sense to you?
I guess you just elaborated what you've already instructed.
Yeah. That's what I was trying to conform it to. Okay. I just wondered, because some people read it and some don't.
It's just the print is so small and it's little. That's just kind of, so it's like tedious, but what
Bring
you
it out here.
right. That's a good idea. Yeah.
Okay. That's a quadratic equation. In this case, A, B, and C are all 1, right?
Yeah.
Okay. So we've got -1 plus and minus the square root of 1 squared minus 4 times 1 times 1, all divided by 2. Okay? So this becomes -1 plus and minus the square root of 1 minus 4, all over 2. Or -1 plus and minus the square root of -3 over 2. The square root of a minus number is called an imaginary number because there are no numbers that if you multiply them together give you minus anything. Because if they're both negative, there's going to be positive. If they're both positive, they're going to be negative. And if one's positive, the other's negative, they're not the same number, right? So that's what we call an imaginary number. So what we have defined, and I think, well, it was another German that invented this concept. And sometime, I think in the Middle Ages, the Arabs were approaching it, but it didn't make any sense to them because it doesn't make any sense to anyone. Okay, so we define the number I as the square root of -1. Okay, it's a definition. So the square root of -3 can be seen as the square root of 3 times the square root of -1. Square root of 3 is a real number. So in this case, we would say that this is going to be -1 plus and minus I times the square root of 3 over 2, and I accept that as an answer. So anytime you see a negative number as a result of this, the answer is, there are two ways to state the answer. The answer is imaginary, or there are no real number answers. Because in each case, the square root of -1 figures. So you can see that. So I just want you to be aware that if you see that, you can always pull the square root of -1 out and call it I, and then look at the square root of what's left. All right?
Yep. Hey, can you do one more on the board?
Of which type?
Of this type, of this quadratic formula?
That ends up with the square root of a negative number?
No, just with the square root.
Okay, yeah, sure. Yeah,
One
just-
question before you erase all this. So like, let's say that 3 was like a 9 and you could simplify it then to be a 3. So it'd be an imaginary 3.
3I, yeah.
3. Okay. So
3
it'd be
times
3i.
I. Yeah, we still need to have that imaginary root in there.
So the I is then behind the 3?
Yeah, it
And
can
that's-
be. I put it in front of the radical so that it's not something that says the square root of 3I,
Okay.
right? I just put it in front to make sure that it wasn't confused. Yeah, we'll do another. I'm
Just
perfectly happy
with
with
just
that.
with the ones that you can't use the factoring.
Yeah, okay, something that we can't factor.
Yeah, something
Gotcha.
can't factor, yeah.
No problem.
Cause I get it how to do it with the factoring, but the ones without factoring, it's just that setup is critical. It throws me off.
Okay.
That was weird.
What part was weird?
I don't know what that was. Somebody
that
came
or
running down and
It was.
It was both.
It happened at the same time.
oh, it did. What happened up here? I missed it. 'Cause I was supposed to be watching this weird stuff.
I missed them both.
And you heard a thunk, right?
Right.
That knocked this thing off the board.
Oh, okay.
That's hilarious.
I heard that.
Knocks that off, and then someone just rapidly runs through and then runs back.
Yeah, color hair, so
Like
everything.
Speedy Gonzalez on crack.
Yep.
He said, "Yep."
All righty. Let's make up one. Let me find a good one. Let's do this one. Okay.
Mhm.
Little variation here. In this case, A is not one. So we have A is,
3,
B is,
4, minus
-4.
okay, and C is.
He was on it, man. He's on it.
1.
1.
All right. Okay?
Okay.
Great. So we've got X equals minus times -4, right? Plus and minus the square root of -4 squared minus 4 times 3 times 1, right? All divided by 6 in this case, 2A, right?
Oh man. It's
Wait,
the
Where'd I
setup.
lose you?
Did you just say 2? It's just 6?
2A, remember?
2 times 3.
We've got 2A, 2 times 3 is 6.
2. Oh my goodness, I've been
Remember,
forgetting that
2A.
A this whole time.
We've been putting 2
I
under because
forget
all
about
our A's are
the
big 1.
Goodness.
Dang.
But
I
they don't
haven't.
have to be.
I forget about the 2
The
X.
A.
Yeah,
The A.
that's why I say write down that formula.
Right.
I've
so
got it
you
written
don't
down in
forget-
3 places already, and it was written down wrong.
Uh,
Like all except for the first place.
yeah, don't forget the A,
Oh no.
okay?
Okay.
So now we have
That's why.
X equals 4 plus and minus the square root of -4 squared is 16 minus 4 times 3 times 1, which is 12, right? All over 6. Right? So X equals 4 plus the square root of 16 minus 12 is 4 divided by 6. And 4 minus the square root of 4 divided by 6. I tried to do the same thing. Okay. So we've got X equals 4 plus 2 divided by 6. So X equals 1. 4 plus 2 is 6 divided by 6 is 1, right? And 4 minus 2 over 6, which is 2/6 or 1/3. So X is 1 and 1/3. Two different answers, right? that help, Bernard?
Yeah.
So the key is remembering, that's why I say you have to be very careful that you set the formula up. So you have to remember all the components, minus b plus and minus b squared, the square root of b squared minus 4ac, all over 2a. And you're going to see on the in-class work that you'll get started on, a number of formulas that have a as not 1. Okay. Now, many of those actually can be factored, but it's a different and more complicated method. So we won't be going into factoring equations where a is anything but 1.
Okay,
Okay.
that helps.
Yeah. Does that help? Okay.
Yeah, that
I'm
helps.
going to leave that up there for a while and give you guys this in-class exercise to get started on. It's a little shorter than the last ones. It's only 20 questions instead of 30, but that's okay. It also is a little more complicated since you're dealing with quadratics. Where is it? There you go. All right, Trevor. And Jessica. Also, your assessment for this week is online now. Daniel, I'm about to email this to you. Okay, so I'll keep this recording in case anyone asks questions and I decide to write on the board. So other than that, I'm going to stop talking and let everybody work. So Daniel, that should be in your inbox now.
Hey, good question, Jess.
I got it.
Square root. That's just square. That's all it is.
So do you want me to just work on the Excel sheet itself?
I have a question.
Sure.
When you divided out this 2 to simplify,
on these guys. And we divided out this 2 here,
Right.
but we didn't do anything between this.
No, we just did the coefficient.
So when I want to divide out this -6 and 2 to simplify this one,
Right.
because this 76, I can't. It's not a perfect. 76 is not a perfect square. So
You
it's gonna
sure
work.
it isn't? You sure 4 isn't a factor of it?
I see what you mean. So back down that 76. Okay. Okay, I see where I need to go from here.
Okay.
So 76 divided by 4.
Right.
19.
Yep.
Odd number. Okay.
So that's why I say, you may want to do a little factoring, a little factor table.
Okay.
And especially with even numbers, you're going to take at least 1, 2 out of it.
Yeah.
And then keep going.
Okay.
And what you're going to get is 2 times 2 times 19.
So,
Sorry, I'm slow.
this is factor the following. Okay. Did you guys do number 1 yet? Just want to see if I got the right answer.
Yeah, this is a joint group, so you guys can work together.
It's definitely
Oh, you
two.
No, you're
We were
good.
just doing that there. Have you done this one?
No, I haven't.
I was doing number 27.
Oh, you was?
In the middle of the ring.
Oh, yeah.
Yeah.
So did you want us to find the like x equals blah blah blah?
Because I feel like I might be able to get it done. I only got like 3 more questions left. You want to rock through those with me in the next 10 minutes?
Hey, you want to walk the floor?
You want to rock
I
through
didn't even
them?
started on them. I didn't even started on this one yet.
Well, then you'll have a good head start. You can rock. You can do it
Yeah,
from
let's see.
down, the hardest to the easiest for you.
Right. I don't know. I'm just
Mr. Burke.
Okay. Hang on.
Let me
Do
see.
you want to go to?
I'm doing it now.
Okay. Hang on.
It
Which
looks
one do
like
you want
the
to do?
same
Do you want
one.
to do 27?
Looks like the same one. Oh, let me write it out.
Different. Yeah.
Let me write it out.
Okay. Yeah. You write out. Which one are you gonna write out?
20. Oh, you said 27.
Yeah, that's what I just did. If you want to do 27, or we can just do 28. If you give me like 2 seconds, I'll finish 27. Or we can do 27.
You already got it?
27. Yeah, I just finished 27. We're collaboratively working together. You want to collaboratively work together or not?
I was saying, you're already doing it. But it's not collectively. We're not collectively doing it.
We gotta hop on the same
But
page
look,
here.
look.
Okay.
27.
Okay. Yeah. If you want to start writing it out, then I'll help you finish 27, and then we can start putting it together. How's that sound?
Yeah, that sounds pretty good.
Yeah. All right. Yeah, I think.
This is quadratic. Okay. You see, this is the. Oh man, this is. You have to use the formula. That's,
Yeah, we're
you
gonna
have to
use,
use
we're
that.
gonna plug them into the formula. So I know it. Look how big you write. You can take like 10 pages.
No,
Do you want to write on the back of this page so you don't let me turn on the page?
no, it's okay.
No.
Just learned the formula like 5 seconds ago.
I know, it's best to apply it right away so that you don't forget
Right,
it.
right,
know?
right. Okay, so let me see. We got A, B, and C.
Yeah, so I wrote my A, B, and C out. 1, 6, and then a negative 10.
Right.
Mhm.
Okay.
So then, now let's start writing out the whole thing. So x equals negative 6, right? Because it needs to be negative b. Negative 6 plus or minus. Plus or minus. Just keep both of them for right now. And then the square root of 6 squared minus 4 times 1 times negative 10. And put that in parentheses. Multiplication sign. And you just want to keep it together. So here's the multiplication sign. That's why you want to keep these in parentheses just so you can separate two symbols. And then all of this is over 2.
Mr. Burke, can you hear me?
2a, which is 2, 1. So 2. Yeah, either way. But that way you don't forget that there's an A, because we forgot. Yeah. So okay, so then I broke this down further. 6 squared. 6 times 6 is going to be 36, right? So x equals negative 6 plus or minus 36 plus 40, because negative 4 times a negative 10 is going to be a positive 40. Negative 4 times 1 is going to be a negative 4, so I just disregarded it.
Okay.
And then so negative 4 times a negative 10 is a negative, or a positive 40. Positive 40. So 36 plus 40.
So you got 6 times 6.
6 times 6 is 36.
Yeah.
Yep. So 36 plus 40 all over 2. So over 2. And then I split them up from there, but you don't have to. You don't want to.
You did.
Because we have to go another further step. So it's 76. 36 plus 40 is 76. Yeah, so I'll put the plus and then I got the negative 1 too. And then both of these are over 2. But then also, if we go back to, I don't know if we would discuss this one together, if I just asked you. No, we did this one together. Up on the board. Did you have this one written down? Okay. Well, this one's number 26, so you're probably going to want it written down too. So when we have no, because this negative, this or the so there's the 76 is not a perfect square, but you can break it down. So like 24 is not a perfect square, but it's 4 times 6 equals 24. So 4 times 6 inside of the square root is now square root of 4 times the square root of 6, which is 2 to the square root of 6. Did you see how 24 broke down into 2 to the square root of 6?
And do it again.
Okay.
How you explain it?
So 24. Oh my goodness. I can't even. 24. When we do this thing, 1 and 24, and 2 and 12, 4 and 6, 12, and sure 3.
No.
Sure, yeah, I don't know.
Yeah, 3 times 8.
But either way, this one here is a perfect square. 4 is a perfect square. So you want that one right here. So 4 times 6. So that way you can reduce this one down further and get it out of that square root. So it's a 2.
Where did you get the 4 from?
4 times 6 is 4 times 6 is equals to 24.
So there's 2 times 12.
Yeah, but 2 nor 12 is perfect square. So you don't want to use either one of those because then it doesn't reduce.
Let's see.
Because it's not a perfect square. Because like 12 is not a perfect square, and because there's only a few perfect squares. You know what I mean? 4, 9. I can't name them all off. I'm not super smart like you guys.
A perfect square is the square of a whole number. So 2 2 isn't a perfect square because there's no whole number, single whole number that multiplied by itself will give you 2. The square root of 2 is 1.414.
Oh, so a number times.
Itself gives you a perfect square. So 9 times 9 is 81. So 81 is a perfect square.
Mhm. But 76 is not.
76 is not.
Do one more example for a perfect square.
8 times 8 is 64.
64. We should write them
Yeah.
down. You should look them
Yeah.
up and write down all the perfect squares. All the
You know,
prime
like
numbers.
12 times 12 is 144. So 144 is a perfect square.
Yeah. So all your ones, you know, you should
But
just
there's
write them all down.
there's something else that you just give me one more variation or one more example. It'll click. It's just not clicking.
Okay.
Like-
Well, okay. If you take like 13 times 13, we had that on the board.
Right.
13 times 13 is 169. That means that 169 is a perfect square of 13. So a perfect square is any integer multiplied by itself.
By itself.
Yeah.
And so 2 is not
Yeah.
because you can't multiply 2 by
By anything but 1 to get 2.
but you get to 2.
But it has to be the same thing multiplied together. So 2 times 2 is 4, which is a perfect square.
4 is a perfect square.
Yeah.
Because 2 times 2
Right.
equals 4.
Right. So if you just think down the
So
The
3
times
is not
table.
a perfect square because you can't.
3 itself is not. But 9 is. It's the square of 3. That makes sense? Or more sense?
It makes a little bit more sense.
Yeah. There, I think,
I'm gonna just have to look at the tutorial.
yeah, if you look at chapter 1 of the text, I think it goes into some of those concepts.
I'm sorry, Jessica, I didn't mean to throw you off.
No,
Oh,
no
don't worry.
worries. No,
We're here to help
ask
each other.
questions. Yeah.
76 is not a perfect square. Therefore,
No, but he helped me out in suggesting that it is factorable by 4. So when you divide 76 by 4, you get 19. So you've got a square root of 4 and then the square root of 19. So that you can just reduce out to just be 2.
Okay,
to
Trevor,
19. So
you need to go back
negative
and do
6
the
plus
assessments
2,
in weeks 1 and 2,
negative 6 minus
and
2,
the discussions.
19,
I've opened
all
the
over
discussions
2.
up. So
And then
please
when
do
you do
that,
that,
because we
you
need to
can,
get your grade up.
simplify it further. And then
You know, and then
2,
Paul
6
was just
divided by
excited
2
when I
is a
told him
negative
that you
3.
brought in all those
And then
assignments on
it's like
Monday.
him
So,
because it's now
well, he
1,
was. We
and
all
the
want to see
1
you
in front of him
succeed.
doesn't matter.
So,
So, and this is just a comma.
and I'll get everything else
My
posted
second
in the
answer
next couple
here
of days.
This is the negative
Um,
3 minus.
But also, there
So
are
it's just like this.
homework assignments
that last step.
look like that. I gave you that.
Really,
They
really
have
fast.
video links. I
So
gave
when
you one for
when
this
when
week.
come to a
You
perfect-
can
when you come to a
download
square root
the
and it's
first
not
week. I
perfect,
think you didn't do
then we're
that.
gonna look into trying to simplify it.
So you
and
can
do it two
download
different
that.
square roots.
So
Um,
step 49.
Just let me go back to the grade book right quickly.
Because what equals 49? 7 times 7, right? So that's a perfect square. 7 is the answer to
Okay.
the square root of 49. Right?
Right.
And then like, what's the square root of
And good,
9?
you've been doing checkpoints. Great.
3?
And
Yeah.
you went back and did those
Yeah,
last
so
week.
it's-
Excellent.
So any of these that are not perfect
Um,
squares, we need to find perfect squares within them.
You need
like
to
4 or
look
3.
at your,
Then we
you
can
need
just,
to
like,
read
then
the
you wanna take,
description
like,
of the
76
LRA research paper. and write- Start writing the progress
I don't know
reports
what they
because the
were,
whole
but it was
paper
like
is due this
2.
weekend. So
Right,
write the
yeah,
progress
yeah,
reports
yeah.
and get them
But
to
But
me.
he just suggested
Okay.
4, so I just went
But
straight
you've
to
got,
4.
and we have the week,
And what you're
you've
looking
got the
for on this
assessment
side
from
is
last
something that you
week.
can make,
The
that you can get rid of that square root.
assessment,
So just 4 is
yeah,
perfect.
assignment
So
1
4,
from
you wanna
first
look for
week,
4
which is,
particularly,
you
I
can
guess, is what I'm gonna
access
guess.
that through readings
Because
and
4 is gonna be
tools
perfect. 4 is gonna be one of the
in each week,
one of the most common ones.
and
So
just
it's a-
download it
it's a little tiny
or
perfect
fill it
square.
out online
What about-
and
what
upload
about-
the answers.
56.
And
56.
let's see, I haven't finished grading that one yet.
Let me see.
Pardon? Yeah, there you go.
Well, yeah, 56
So, yes,
divided
Is that
by,
okay? Great, I'll see you then.
What,
7 times 8.
7 times 8? So
Adios.
but 8 is 4 times 2, right?
4 times.
Okay. I
So you
see
can
what you're
factor
doing.
4
Yeah,
out of
yeah.
56 and have that 2
7 or
times the
8.
square root, 2 times 14 is, or 4 times 14 is 56.
The short is.
So you can, so that becomes 2 times the square root of
2.
14.
Square root of 14.
So
Okay.
the square root of, so this 56 a perfect square?
No, but it is composed of 4, which is a
Which
perfect
is
square, and 14, which is not.
Okay.
So then what? Since the 14 is not a perfect square, but the 4 is.
So you've
yeah,
got,
it's just
yeah,
2.
go ahead, Jessica.
It's just 2, the square root of 14. You know?
And then you do that little, that.
Yeah.
will come
So
down
if
over
it was 56, we would take then 4 times 14. Yeah. So then it would be 2. 14. So this is a simplification of that. This is that last step. That's how you do that.
I get lost.
Okay, I have a question before we go because I know we're getting close
Sure.
to time, but I just want to get it square before we
Okay.
go because this is the last time I get to see you before Monday.
That's right. Well, you can always email me.
Yeah, true. So this one here, I would understand factoring it, but then the equal to 0 means you want us to find the answer to x, right?
Well, just factor it.
Because the
Okay?
factor.
And then
so,
the 2 factors would equal 0.
well, if I factored it, then like the x is common, so
Yep.
it would be 1 plus 7.
X plus 7.
What?
It's x squared, right? So it'd be x plus 7.
Oh, x plus 7. Yeah.
So you've got x times x plus 7 equals 0.
X. And that's the answer?
That's the answer.
Oh, okay. You don't want us to find.
I didn't ask you to solve. I just said factor.
Yeah, that's what I was confused about. Okay, because I knew I was probably trying to make it more complicated than it was. That's usually where I go wrong.
Yeah, me too.
Thank you so much. I do appreciate all your help. Oh, and I meant to, yeah, of course. I meant to get this done before class is over, but I'll have to turn it in on Monday.
That's okay.